Okay, so it says if a particle moves in a straight line according to this function, find the maximum and minimum velocity. All right, so when we were talking about finding the absolute max and min, you have some function, right? We had some function equals whatever. What did we use to find the critical numbers of the function? What did we have to use to find the critical numbers? Anybody know?
We would set the derivative.
That's right. We use the derivative. We use the derivative to find the critical values or critical numbers. So this means we want to find the critical values of velocity. So in order to find the critical values of velocity, what do we have to find? What do we have to use to find the critical numbers of velocity? Anybody?
Acceleration.
You have to use acceleration. That's right. So the first thing we want to do here is we want to get the velocity function. And we need to tell the person that we know velocity is the derivative of this problem. What is that power of 4? Does that say 112t to the 4?
Yes.
Okay, so we're going to multiply the 4 in front, and the 4 and the 12 will reduce to 1/3, and that would be t cubed. And then that's a 3 times this 3 and this 3 will reduce. So this is going to be minus t squared. And then I take that 2 in the front, which will reduce with this 2 in the bottom. So this is going to be minus 3t. And then 1 times 4 is 4. And the derivative of 7 is 0. So there's my velocity function. Now this is what I'm going to use to find my max and min. But I have to find the critical numbers first. So I'm going to say that S double prime is going to equal V prime is going to equal A of t. And you could even just use derivative of V on this one because it's not really asking, well, it is going to ask down here, so it's probably good we're doing this. So I'm going to take 3 times 1/3, the 3's reduce out, and I get t squared. Multiply the 2 times -1 and get -2t, and 1 times -3 is -3. So I'm supposed to know my critical numbers occur when the derivative equals 0. So maybe I'm going to put v prime equals 0. We want to know where that works. So I factor that to t minus 3 and t plus 1. Okay. So when I do this, I'm going to get t equals 3 and t equals -1. Now something I've not mentioned yet, did anybody notice this right here? I hope you notice this right here. That means we do not care about that -1 because it's not in our interval. Now sometimes they'll make this -1 be the min or max, and you use that and it's not in the interval, you're going to be wrong because we're only worried from 0 to 4. So the critical numbers that we're going to plug in, the critical times are this 0 endpoint, this 3, and that 4. The endpoints, and then notice they've got equal signs here because that is the same as saying include the endpoints. So that's the same as saying this because they have equal signs. These two things mean the same. So over here, I want the velocity max. So I'm going to plug 0 into this stuff. So I get 0, 0, 0 plus 4 is 4. And I'm going to plug 3 in. So 3 to the 3rd is 27. 27 divided by 3 is 9. So that's 9. Minus 3 squared is 9. Minus 3 times 3 is minus 9. And then a plus 4. So that's going to equal -5. And then plugging 4 in. 4 cubed is 64. This is a beautiful number. So I got 64 thirds minus 16 minus 12 plus 4. So let's add these ones together I got here. So that's -28 and 4 would be -24. And then I got to get a common denominator. Okay, so let's see, we're going to get 64 thirds minus 3 times 4 is 12, 72 thirds. So what is that? And somebody check my math because I'm doing this in my head. It may not be right. So this up here at 4 is -8 thirds. So somebody check that if you would.
That's correct.
All right, so I hope you know -5 is less than -8/3. That's -2 2/3. So this is my min, and this is my max. So the question says, find the max velocity. So again, this goes back to the ordered pairs. If it said, what's the max, somebody asked at the very beginning, what's the max velocity? He would write 0, 4 down if he wants you to give a point. But I don't want you doing this because this is not what you got to do on the AP test. So you would say velocity has a max equal to 5 at t, 4, not 5, equal to 4 at t equals 0. And then velocity has a min equal to -5 at t equals 3. Okay, and then this is the reason. And we're going to come on down here and do this last part. It says find the max and min of acceleration. So we got acceleration. We found it up there, right? So I'm just going to write it down again. You don't have to show them where it came from because we already showed them right here. Okay, so I'm just going to write it down so we have it. So what do I have to use to get my critical numbers of acceleration?
The derivative of
The derivative.
acceleration.
So I need to do the derivative of this. So a prime at t is going to equal 2t minus 2. So I set 2t minus 2 equal to 0, and we're going to get t equals 1. And if you need me to do those steps, let me know and I'll go through it all. Okay, so again, we are still on the same interval as up here, 0 to 4. So we're going to do a t-chart, and we're going to plug in endpoint, the critical number, the other endpoint, and we're going to plug those into acceleration. So I'm going to plug 0 in. 0 minus 0 minus 3, -3. I'm going to plug 1 in. 1 minus 2 is -1 minus 3 is -4. And I'm going to plug 4 in. 16 minus 8 minus 3 is going to be, what is that, 5, I think? So somebody check my math, make sure I didn't screw up. So here's my min, here's my max, and I have to write down, oops. So I have to write down acceleration has a max equal to 5 at t equals 4, and acceleration has a min equal to -4 at t equals 1. So that's how you got to write them. And again, if he asks you for the points, the minimum point, if he on this quiz, might look like that. The maximum point on this quiz might look like that. So all you're going to do is use whatever your ordered pairs would be if he asks for points. Questions? Anybody else have anything they want me to go over?
I'm still a little confused on 15.
Okay, good, because I forgot to film that. So let me put it back up there and go back up there. Okay, so I'm going to try to explain this to you again using stuff that we've not covered yet, but you can also look at this. So if you think about velocity, see how this is -3? This value right in here is -3, and then -2 and -1. This is telling you how far left it's moving and how rapidly, kind of. It's at a velocity of -3 here, so it's going really fast. If you look at this value right here, maybe this is 0.25. So the velocity is kind of slow right there. It's not moving real fast. And then it goes and it looks like this is maybe at -0.5 for velocity, right? Maybe that's halfway between. So if you look, it's moving left kind of fast, and then it's kind of slowing down, but it's moving left that whole time. And then it moves right, but it's going extremely slow moving right. And then it goes left again, and it goes faster than it was moving to the right, and it goes left all the way to there. Maybe this is the best way to teach you to how it is right now. But what I was telling you was the area, well, we're going to learn next after break is we're going to learn that integration, which is the opposite of derivative. In other words, going back to the position. The area between the curve and the x-axis is how far the object is. That's the position. So if I could draw a straight line up here to that, this area here is the position, how much the position is basically changing. That's how far, that's the position. And then this is also position moving left. Okay, and then this part is position moving right, which I hope you can tell that little area right there is a lot less than these. So again, it's going kind of fast left and then it slows down and then it comes back right. It stops just for an instant and then it comes back right, but it's going really slow and doesn't go right very long. And then it comes back and then it goes left more because this area is bigger. It goes faster left to where it goes to another stop and then it goes there. So this thing right here would be time 2, and this thing right here would be time like 2.8, where it stops right there, and then this would be time 4, and then it goes right forever. And this thing was going left forever before this, right? Because these go up and down. So the furthest left again is time equals 4, t equals 4. Now if you put x equals 4, it's fine because he's got an x here. But up here, he's got a t. So, oh, wait a minute. I lied to you. We're supposed to stop. We were supposed to start at t equals 1. So let's say t equals 1 is right here. And we're supposed to stop at 4. So maybe 4 is here. I don't know. 4 is, wait a minute. Oh, I'm sorry. 4 is right there. So I actually did more than I should have done because we're not worried about any of this stuff. And if you think about it, if I'm starting at 1, it even went further left because it's not going to hit this thing for a while, right? It's going to come down and eventually hit it. Does that help?
Yes, thank you.
Okay. Does anybody else have any questions on anything? Okay, I do not have, I might have time to do the notes for 5, I think I'm on 5, 6. I'm going to look at that, and if I have time, I'm going to do those notes now before 9:15 when the next class starts, and then I'll put those up. And then later today, I'll do the notes for 5, 7 as well. So again, you have until 11:59 tonight. You have until 11:59 tonight to do your quiz. The access code is 5.3. I'll probably send a reminder out about that at the end of the day after my 5th period class. So all those people that don't come to Zoom will have a chance to take it. And again, try to get people to come to this thing. And the more questions you ask, the better you're all going to be. I love why questions. Why questions are the best. Okay? Anybody have any other questions? All right, so again, tomorrow there's a Friday Zoom. Oh, I want to show you this real quick. So let me opening up my Canvas page. So tomorrow, if you want to come to the Zoom, this is for you to come and ask any questions you want. It's down here where it says Friday 9 to 9:45 Zoom. This is the Fridays where you're going to come to Zoom right here. And this is to clarify any questions you have. Okay, so if I look right here, if I go to daily assignments and look at where we are right here today, this is Thursday, and I come down to this week, this is the 3rd, and I open this up and I come down here to the 3rd. See, this is the worksheet you're supposed to work on. Here's the key to that worksheet. We're supposed to take this quiz today. Tomorrow is Zoom if you have questions from 9 to 9. Yeah, that's right, 9 to 9:45. So that's where you would click on that thing if you have questions. Anybody else got anything? All right, I will see you guys on either tomorrow's Zoom or I will see you on Monday. Have a great weekend. If I don't see you tomorrow, stay out of trouble, do what's right, not what's popular. And stay safe.